Assalamualaikum warahmatullahi wabarakatuh. A very good morning to Dr. Izril. My name is Mohammad Zarul Azam bin Tajri. I'm from Group 2. Our group is assigned to do experiment 3, which is vapor compression refrigeration. So our group members is Mohammad Haziq Haiqal bin Hamdan, Zheng Yee, Muhammad Asif Izril bin Sharuddin, me myself Mohammad Zarul Azam bin Tajri. Then let's look to our introduction. So I will explain to you what is our introduction. In this modern era, heat pumps are by far the best system for commonly used for cooling. These are heat pumps that are used to transfer heat from a low heat reservoir to higher heat reservoir. There are two types of system. First, we have refrigerator and freezer. Other than that, we'll use heat pump as the main component of operation. COP, standing for a performance coefficient, is introduced to serve as the ration in which the cooling work required for the type of machine can calculate the cooling process it goes through.
My name is Mohammad and I will be presenting about theory, working principle, and experimental setup. So, for the theory, the first law of thermodynamics stated that energy cannot be created nor destroyed. And the second law of thermodynamics stated that heat always transferred from a high temperature space to low temperature space. But this experiment shows how the second law can be reversed and heat flow from low temperature to high temperature spaces. This effect can be achieved by supplying work to the system. This process is known as cooling system. As for the working principle, the liquid that is inside the system is continually expand at the expansion valve and compress at the compressor to change the matter state. And during the change of matter state, the heat from the evaporator is absorbed and then released at the condenser. This is the experimental setup for this experiment.
So for methodology, this experiment has 7 steps here. So first step, we need to close hand valve 2 and 4. Second step, we need to open hand valve 1 and 3. Third step, we need to start water flow through the system. And fourth step, we need to switch on the compressor. Step 5th, the volumetric flow rate of refrigerant, cooling and heating water were set. To reach steady state condition in the system, the compressor was left to run for a while. Step 6, the temperature T1 to T7 was measured. To fill out the table 1, we need to read the pressure in condenser and evaporator. On reading the manometer, 1 bar must be added to the value read to obtain the actual pressure. And the last step is the flow rate of the refrigerant was changed. Wait until the cycle reach its steady state condition and repeat step number 5 and number 6.
So, hi guys, my name is Mohammad Izril. Today I will present about the results that we got during the experiment and the safety procedures that we do, the procedure that we did throughout the experiment. This is the results that we got during the experiment. This is the graph of rate of heat transfer at evaporator and rate of heat transfer at condenser. We calculate this data from the data that we got throughout the experiment by using the equation of M is equals to QH, which is QH is enthalpy. Next, I will present about safety procedures. The first step that we did during the experiment is we open the valve, and the second one is the water pipe was turned on, and the water flow rate to the evaporator and condenser was set as 25 gram per second, and maximum this is for the water flow rate to the condenser. The third step is the main we switch on the main switch, and the cooling system, we allow the cooling system to be stable approximately 10 minutes. And the fourth step is we taken the temperature of T1 to T4 from the temperature indicator by adjusting the switch of the temperature. And the fifth step is the temperature T5 to T7. We obtain it from by using the thermometer, and it was recorded manually. And the last step is the experiment. We repeated 4 times by changing the flow rate of water in the condenser in between 35 to 40 rep per second.
Salam sejahtera to everyone, and now I will continue to the discussion part. The first part of discussion is to calculate the rate of heat transfer that occurs in the evaporator and condenser for the 5 test run and discuss the result. The rate of evaporator Q can be calculated by formula Q equal to m delta H, where m equal to 0.025 kg per second and Q is the change of enthalpy that can be found in table A4 of steam table. From the calculation, we found that QL1 equal to 58.24 kW, QL2 equal to 58.18 kW, QL3 equal to 58.07 kW, QL4 equal to 58.05 kW, and lastly QL5 is equal to 58 kW. Next is calculate the rate of heat transfer at condenser. The same formula Q equal to m delta H is used to calculate rate of heat transfer at condenser. From the calculation, we know that Q1 is equal to negative 72.51 kW, Q2 is equal to negative 67.07 kW, Q3 is equal to negative 62.64 kW, Q4 is equal to negative 57.39 kW, and lastly Q5 is equal to negative 52.49 kW. The second part of discussion is to explain the effects of changing the condenser flow rate T1 to T5 to the compressor power. Draw the graph and discuss the result obtained. So, the following is the graph of condenser flow rate versus compressor power. We can assume that compressor power is increasing as the condenser flow rate increases. The compressor capacity will increase also as the condenser flow rate increases. Lastly is the parts of conclusion of this report. As a conclusion, the coefficient of performance CORP is directly proportional to the evaporator rate of heat transfer QL. It can be said that the condenser flow rate is proportional to the compressor force. So, as the condenser flow rate increases, as the work input will also increase. Thank you.